Hi, this is Ben McIntyre, the creator of the Access Extension Framework. Firstly, why the Access Extension Framework? Well, I'd gone through a period of several years of developing in SQL Server-based environments, and I'd developed a set of tools in a standard user interface style. The framework was the result of the need to standardize my product upgrade process and user interface style across all platforms, as well as providing ready-made solutions to a lot of the problems that Access developers tend to spend hours or days working around. So let's have a look at the framework. The framework is delivered as an MDB file, and it's 100% unlocked, fully 64-bit compatible native Access code for zero distribution hassles. It has a small footprint since nearly all the framework is in class modules, and they're accessed through the base XF object, which also provides IntelliSense when navigating through the methods. It's designed to be imported into new or existing projects with a very low likelihood of collision with existing code. Installing is as easy as importing a setup form and clicking a button. Firstly, let's look at what minimal configuration provides. This is the configuration where only the code modules are loaded. There are two instances of the string library, one case-sensitive and the other case-insensitive. They contain a wide range of string functions, including all of the standard .NET ones, and more advanced ones, like here, a split function similar to the VBA one, but that splits on a set of delimiters instead of just one, or the string debug helper to help you work out exactly where that concatenation is going wrong. There are utility functions to manipulate and configure page controls and interact with the user and operating system. Here we see a function to automatically select the only value in a combo if it contains a single row. Another one to move datasheets to the top, to go to the first visible control on a form, hide a control, checking first to see if it has the focus, and if so, moving the control to a second named control before hiding it to avoid an error. Another example is control tagging, based on the tagged controls action method. Let's suppose we want to show and hide controls on a form, depending on the value of a checkbox. We can set the tag property of the form, which is a general use text property. Note that the framework recognizes multiple tags separated by a semicolon. Then we can set the after update event on the checkbox to call tagged controls action, passing in the tag name and specifying the action we want. If we want to add another control to the group, it's as simple as pasting into the tag property. No extra code is needed. A sample of the interaction library offers file name and path extraction, HTML encoding, suppression of errors when opening forms, reading binary objects from the database, including automatically stripping bitmap OLE headers from images written using the Access user interface. There is a library of commonly used external DLL calls, tested for both 32 and 64-bit Office. They may be called directly, or the interaction library offers some more user-friendly methods for some of the calls. The framework contains several new classes that provide enhanced functionality in code. A dictionary class enhances the built-in collection objects by allowing iteration of both keys and values, and contains a lot of helper methods and error checking built in. The dbConnect object wraps a database connection, ADO or DAO, and allows it to be passed around between code methods. The xf.dbConnect object is a built-in object representing the current database. It also offers some handy data retrieval options, such as returning column values as a delimited list, returning a named key and value column as a dictionary, or returning an entire row as a dictionary with the column name as the key. Note that here we are using a helper method of the dictionary to list its contents, rather than iterating through it manually. The data list is like an in-memory record set on steroids. The data list and extended data list allow manual population or reading data from a database with an SQL statement. Here we can see data being read from the customers table. We can elegantly iterate through the data. We can set up hashed lookup of primary key column values for speed. We can dump column or row values as delimited lists. We can sort on multiple columns, ascending or descending. By using the extended list object, we get multi-column filtering with additive or subtractive results to simulate OR criteria. The extended list object also gives us grouping with aggregate functions, a lot like Access reports. We can use the data list as the basis for complex calculations that are beyond the scope of SQL. We can also bind a data list to a combo or list box to create lightning-fast sorting and filtering screens that don't requery the database. The ParsArgs base class is designed to pass values between forms or reports. We can see here a sample screen that passes data as a dictionary or a strongly typed object, complete with callbacks where the second screen is not a modal dialog. An SQL cache object allows the caching of result sets from SQL in a data list. Note how dbRead or cached is returned by the debugging trace, depending on whether the data has been read from the database or returned from memory. Clearing the cache will read the data from the database again. Finally, there's a global data storage function to allow values to be passed to queries and form or report controls. Here we're storing a value and then retrieving that value as a criteria for the SQL query. This is the optimum solution in Access for this problem. The instruction manual covers the problems with the other methods. Standard mode adds to minimal mode support for deployment and maintenance of the front-end back-end pairs. There's automated front-end upgrade, an integrated back-end schema upgrade via SQL scripts delivered in the front end. Back-end and front-end databases both have version numbers. On the client's network, the front-end databases monitor a specified shared folder location to see if there is a later version of the application there. To update, the developer completes a release in the development environment and bumps the front-end version number. The front-end may also contain scripts to update one or more of the matching back-end databases. The developer uploads the release to the web with the tables still linked to the development environment. The client downloads the update to the shared folder. The next time that a front end starts up, it detects the newer version of the application and updates itself, during the process copying the linked database paths from the old front end to the new. On starting up, the new front end immediately relinks to the client's back ends. Now it checks the back end version, and if it has a later version setting, it prints a message and runs the scripts to update the back end to the latest version. When the other front ends start up, they will auto-upgrade, but because the back end version is now the latest, the scripts will not be run again. To enable full control by the update scripts over the back end tables, the framework contains an SQL preprocessor, adding SQL support for all native Access field and table properties, as well as commenting, scripting of binary data, and many other enhancements. The Control Center contains SQL scripting generation and execution tools similar to SQL Server Management Studio or Query Analyzer, fully supporting the enhanced SQL features and offering scripting of schema, insert, or update statements. The fully featured table linker is integrated into the update process and supports any number of Access or ODBC backends and several different linking scenarios, such as fixed backend location, front-end backend in same folder, and following the path of another backend. The framework provides an error handler that logs to a shared error log table, with a local error log table to temporarily store errors if the backend database is unavailable. A Control Center form manages all the framework settings, offering script generation, editing and execution, diagnostics, management of table linking configuration, and allowing filtered lookup of the error log. The immediate window allows access to a command line tool that allows common commands to be run without opening the Control Center. Finally, the feature pack contains the Shadow Tables feature. This aims to support late validation in the user interface, meaning that validation of form data can occur when the Save button is pressed, rather than when the data is entered. Access is hardwired for early validation when non-empty constraints are enforced on the database, a factor which I would contend is the main reason for the lack of data constraints on the majority of Access databases, which robs us of the main weapon in the fight against poor data quality. The Shadow Tables feature gets around this by automatically creating an exact copy of the back-end table in the front end, but with all the constraints removed. This is called the Shadow Table. Forms can then edit data in the shadow table rather than in the main table, treating it as a temporary unconstrained area for data storage. The shadow tables class manages copying data to the shadow tables before editing and saving the data afterwards, and in fact handles all the CRUD operations. It automatically handles data validation and concurrency, and can validate or save entire structures of parent and child records with a single command. This decoupling of the user interface from data constraints opens up a new realm of possibilities for Access user interface design. Using code-based methods for saving and loading data, rather than the largely focus-driven Access default behavior, also allows for much greater control over how and when data is written to the main tables, including being able to do extensive custom validation without the restriction of being in an event procedure. Thanks for listening, and for more information go to www.arrowoftime.com.